We're going to continue chapter 7, 7.2, hypothesis testing for the mean when sigma or standard deviation of your population is given. So using p-values to make decisions. In chapter 5, we learned that when the sample size is at least 30, it means that greater than or equal to 30, the sampling distribution for the mean, x bar, sample mean, is normal. In chapter 7 in general, you'll learn that there are different ways to make decisions about your claim in a hypothesis testing. We can use p-value for the sample statistics like x bar, and we learned that we can use p-value for population proportion and its sample statistic related to proportion. Recall that when you assume the null hypothesis is true, a p-value or probability value of a hypothesis test is the probability of obtaining a sample statistic with a value as extreme or more extreme than one determined from the sample data. The decision rule for a hypothesis test based on a p-value is given below. So if p is less than equals alpha, remember that alpha is the level of significance, then you reject the null hypothesis.
Dave, right?
So if p-value is less than or equals to alpha, level of significance, then you reject the null hypothesis. Otherwise, you fail to reject the null hypothesis. It means that you support the null hypothesis. Let's take a look at one example. Suppose the p-value for a hypothesis test, the p-value or the probability value is 0.0237. What is your decision when the level of significance is 5%? What's your decision if alpha or level of significance is just 1%? Very well. If the level of significance is 5%, of course 5% is greater than 2%. So this is your p-value and this is your alpha. Since p-value is less than or equal to alpha, we reject the null hypothesis. If alpha is just 1%, of course 2% is not less than 1%. It's greater than 1%. So you fail to reject the null hypothesis. Very well. Let us continue. So you should be asking, how do we find a p-value? First of all, you need to identify your null hypothesis, alternative hypothesis, then you move on to your test statistic. And then after that, you need to find the area related to that test statistic. Then, if you have a left-tailed test, p-value is equal to the area to the left side of the region in your normal distribution. If you have a right-tailed graph, again, p-value is equal to the area on the right-hand side. For a two-tailed test, p-value is 2 times the area on one of the tails of your graph. That's how we find p-value. You can either use a p-value to make a decision about your hypothesis, or you can identify the rejection region. Perfect. Example 2, finding a p-value for a left-tailed test. Very well. Suppose you have a left-tailed hypothesis test. So what's the meaning of that? If you want to get a general idea about the hypothesis test and a left-tailed hypothesis test, you know that the shape or format of the graph is related to alternative hypothesis. Since this guy says you have a left-tailed hypothesis test, it means that your alternative hypothesis is something like mu less than a number like k. So its opposite is mu mean greater than equals to a number like k. Then what's given? Standardized test statistic is also given. It is negative 2.23. Since z-value is given, test statistic is given, you have to look at your z-table, or you can use your calculator to find the area. To find the area, you're looking for a number within the areas. So let us open a z-table. Z-table PDF. Okay, let me download this, open it in PDF file for you. Okay, perfect. So our z is equal to negative 2.23, negative 2.23. So negative 2.23. So the intersection between these two is almost 13%. I'm sorry, almost 1%. It's not 13. You have a 0 next to it. So 0.0 area is 0.0129. This is your p-value, or this area on the left-hand side of your test statistic. Very well. After finding the p-value, we can make decision about our hypothesis test. And the question says your alpha, or level of significance, is 1%. Exactly 1%. Since alpha, 1%, is less than your p-value. Or you can say that since my p-value is greater than my alpha, then you fail to reject the null hypothesis. Example 3. Now suppose you have a two-tailed hypothesis. So it means that your hypothesis testing is like this. Again, the tail, left tail, right tail, two-tailed graph is based on your alternative hypothesis. So suppose in this case, mu is not equal to k. So your null hypothesis mean is equal to a number like k. Suppose the test statistic is 2.14. Decide whether to reject or fail to reject the null hypothesis by having a level of significance, which is 5%. Again, you have to use your z-table, or you can use your calculator to find this little area on the left-hand side. So since z is equal to 2.14, and you know that you have a two-tailed graph, because of symmetry, you get the exact same digit with a different sign, opposite signs. So this z-value on the left-hand side is negative 2.14. Now you use your z-table to find the area corresponds to negative 2.1, 0.04. This area, let's take a look at this. Let me show you. Negative 2.14. So negative 2.4, which is almost 2%. Perfect. This little area is almost 2%. So if you multiply it by 2, you get roughly 3%, which is less than your alpha. Since p-value is less than alpha, you reject the null hypothesis. So again, z is given as 2.14. Since you have a two-tailed hypothesis test, because of symmetry, the other z-value on the left-hand side is minus 2.14. You use your z-table, negative 2.1 and 4. The intersection between them is the area, this little area on the left-hand side. Now, since the area is split in halves, half of it is on the left-hand side, half of it is on the right-hand side, you multiply it by 2 to get the total area. This total area is less than your level of significance. So you have to reject the null hypothesis. Very well. So how do we find this z-value? Z-value, z as standardized statistic can be found using formula x bar minus mu divided by sigma over square root of n. Remember central limit theorem. Sigma over square root of n is the standard error for the mean of sigma sub x bar. So in general, to decide about your null alternative hypothesis, you have to follow the guidelines here. First of all, verify that sigma or population standard deviation is known. And the sample is random. You either know population is normally distributed, or you know that the sample size is greater than or equals to 30. Then, in the next step, you have to form your null and alternative hypothesis. One of the most important steps using your keywords that we discussed yesterday. In the next step, you need to specify the level of significance. What's that? Is it 1%? Is it 5%? Is it 10%? In the next step, you need to find the standardized test statistic, z, which is equal to x bar minus mu, divided by sigma over square root of n. You can also use x bar minus mu, divided by sigma times square root of n. Then find the area that corresponds to the z that you found in step 4. Then you need to find your p-value. If p-value is less than or equals to level of significance, you reject the null hypothesis. Otherwise, you fail to reject the null hypothesis. Example, let's see what's going on here. In auto racing, A pit stop is where a racing vehicle stops for new tires, fuel, repairs, and other mechanical adjustments. The efficiency of a pit crew that makes these adjustments can affect the outcome of the race. Okay, so these are not necessary. A pit crew claims, okay, we found a keyword, claims. Claims that its mean pit stop time for 4 new tires and fuel is less than, another keyword, less than 13 seconds. Again, we have claim, we have mean time, so we know that we're talking about mu, is less than. So what's given? This line gives you alternative hypothesis, mu less than 13. Now you can quickly form your null hypothesis, mu greater than or equals to 13. Perfect. Now you take a random sample of 32 pit stop times with mean 12.9 and standard deviation 0.19. This is population standard deviation. This is your sigma. So sample size is 32. The sample mean X bar is 12.9 and sigma is 0.19. The level of significance is also given 1%. Let us check to see what's going on here. So we identified null hypothesis, alternative hypothesis, okay. In the next step, we have to find the test statistic, which in this case is z equals to x bar minus mu divided by sigma over square root of n. We have all the missing information. We just plug them in. X bar is 12.9. We have it here. Mu is 13. We also know that mu 13. And we have sigma, population standard deviation, 0.19 divided by square root of 32. Sample size 32. If you do the calculation, the z value is negative 2.98. Next step, after finding z, we need to find our p-value. Note that here you have a left-tailed graph. Because of your alternative hypothesis, you have a left-tailed graph. So you just look at your table, you find the area for z negative 2.98, which is equal to something very small. P-value is 0.0014. Is this less than alpha? Of course, this guy is very small. It's almost around 0. So since 0% is less than 1%, it means that you reject the null hypothesis. If P is less than or equals to alpha, you reject the null hypothesis. But what is the claim? The claim and our null hypothesis are the same. I'm sorry, the claim and alternative hypothesis are the same. It's the alternative hypothesis. So you reject the claim. No, you reject the null hypothesis. It means that you're supporting the claim. Okay, let us move on to another example. So according to a study, the mean cost of bariatric weight loss surgery is $21,500, and you think this information is incorrect. Okay, perfect. You randomly select 25 patients and find that the mean cost for their surgery is 20,695. So 25 is your N, sample size. And the mean cost for this sample, so this is X bar. From past studies, the population standard deviation is 2250. So what is this guy? This is sigma, population standard deviation. And the population is normally distributed. Is there enough evidence to support your claim? Remember that you say that it is incorrect. Is not 21,500. Okay. Level of significance is given as 5%. Perfect. So is 21,500. So your null hypothesis is given. Mu is equal to 21,500. So you can form your alternative hypothesis. Mu is not equal to 21,500. And the alternative hypothesis is your claim. Very well. We formed our null hypothesis, we formed our alternative hypothesis. Now it's time to find the Z or standardized test statistic, X bar minus mu divided by sigma over square root of N. X bar is given, 2695 minus mu is also given, 21,500, and sigma also given, 2250 divided by N, which is square root of 25. When you do the calculation, your Z is equal to negative 1.79. So Z value standardized test is given. Now you look at your table to find the area for negative 1.7, 0.09. The intersection between them is this little area on the left-hand side. Now to find p-value, you have to multiply it by 2 because the area is split in halves. One part is on the left-hand side, the other part is on the right-hand side, so you multiply by 2. So p-value is almost 7%. If p-value is less than or equals to alpha, you reject the null hypothesis. Otherwise, you fail to reject the null hypothesis. Since alpha is 5% and p-value is greater than 5%, p-value is 7%, is greater than 5%, we fail to reject the null hypothesis. It means that we support the null hypothesis. Support the null hypothesis. It means that with the information that we have, we reject the claim. So you can say that there is not enough evidence at the 5% level of significance to support the claim that the mean cost of the surgery is different from 21,500.